These are your video notes for Lesson 7.4, Systems of Equations. A system of equations is a set of two or more equations that contain two or more variables. So we're going to start taking a look at problems like y equals x plus 3 and y equals 2x plus 5. These two equations right here make up my system of equations. We're going to start taking a look at how to solve for the values of both variables, y and x. A solution to the system will work for both equations. So if I find in this equation that y equals 1 and x equals 2, if I plug that into this equation up here, that same solution will work. And because our system will have two solutions, you can write the solution as an ordered pair, with your x and your y. Alright, so let's take a look at our first example here. I have y equals x plus 3 and y equals 2x plus 5. These two equations make up my system of equations. So I know that if y is equal to x plus 3 and y is equal to 2x plus 5, I can set these two equations equal to each other. And I can solve this equation for the value of x. So if I subtract x from both sides, I'm left with x plus 5 equals 3. I can subtract 5 from both sides, and I'm left with x equals negative 2. So that's half of my solution, right? I have the value of x now. But now I need to find the value of my other variable, y. If I go back to one of my original equations, y equals x plus 3, I can plug in my value of x into that equation to find the value of y. So let's take a look at what we get. If I have y equals x plus 3, and I plug in my value of x that I found, y equals negative 2 plus 3, I get y equals 1. And earlier we talked about how you can write the solution to a system of equations as an ordered pair. So this would give me my x-coordinate would be negative 2 and my y-coordinate would be negative 1. Let's take a look at another example. So here my system has y equals 3x plus 8 and y equals negative 7 plus 3x. And again, we know that if y equals 3x plus 8 and y equals negative 7 plus 3x, 3x plus 8 must equal negative 7 plus 3x. And we can solve now for the value of x. So let's subtract 3x from both sides, and I'm left with negative 7 equals 8. Now, is this statement true? No. Will it ever be true? No. So this system of equations actually has no solution. Alright, let's take a look at our final example here. My system has y equals 4x minus 6 and y equals x plus 3. Again, y equals 4x minus 6 and y is equal to x plus 3. So I can set 4x minus 6 equal to x plus 3. And I can solve for x now. If I subtract x from both sides, I'm left with 3x minus 6 is equal to 3. To get rid of that negative 6, I'm going to add 6 to both sides. And I'm left with 3x equals 9. I can divide both sides by 3 to find that x is equal to 3. That's only half of my solution, right? I know what the value of x is. I now need to find the value of y. So if I plug in x equals 3 into one of my original equations, 4x minus 6, let's see what I get. Y equals 4x minus 6. So if I plug in my value of x, which is 3, I get y is equal to 4 times 3 is 12. 12 minus 6 equals 6. Now I know the value for x and I know the value for y, so I can write my solution as an ordered pair. X is 3 and y is 6. This concludes your video notes for Lesson 7-4. We'll work on some problems in class tomorrow.